When we are solving a word problem here, solving a word problem involving rational expressions, the best way to do it is to start with a table. Problem in this, the question in this unit would usually be involved with speed, distance, time, or sometimes instead of working with distance, they talk about the job done, like the previous example. But here in this example, they talk about having a group of friends going on a 3 hour bike ride together. 3 hours. So if I'm to set up a table with distance, speed, and time, we have the total time required in this case. It is 3 hours. Come back. 3 hours. Then you ride the 15 kilometer with the wind, blowing from behind. So they're going to go a little bit faster because the wind is to help them out a little bit. And then 15 kilometers straight into the wind. So they're going to go against the wind when they return. With the wind 15 kilometers. Against the wind, same distance. So altogether, the total distance traveled would be 30. I don't know if it will be useful for the problems or not, but I'm going to keep it there for now. The wind adds or subtract 3 kilometers per hour from their speed. What would be their average speed? Let me call it x. This is what they want us to solve, and I will let x be the average speed in this case. This is the average speed, and they will get some help from the wind when they ride with the wind. The wind is to grow at a 3 kilometer per hour, and that will get added to their average speed. This is what they would usually do in the gym when they practice. This will be x will be the average speed. But now as they ride with the wind, that will be x plus 3. Then what about against the wind? Minus 3. Yes. X minus 3 would then be the speed riding against the wind. Once we have the distance and the speed, I can then come with the time here using the triangle you've done back in grade 10. If I want to figure out the time, I need distance over speed. I have the distance here, and I have the speed. When I go distance over speed, that would be the time required. Riding the bike with the wind. I can do the same thing for the second case. Distance over speed, that will give us the time. This is the last column that we spend time on. And that's the column we'll be using to create our equation. I have time with the wind, time against the wind, and this is the total time. How do you bring these together and form your equation? Yeah, add the two together, and the total time will be 3 hours. So here is your equation. Once you add them together, here is your total time. And we can now solve this equation using the lowest common denominator. The denominator involves x plus 3 and x minus 3. Bring them together, that will be your LCD. Here, I'll times it by x plus 3, x minus 3, times it by x plus 3, x minus 3,
and times it by x plus 3, x minus 3.
This is for us to reduce with the denominator. This is for us to get rid of the denominator.
The denominator can be reduced with the part of the LCD. Same thing for the second one. And we will end up getting x minus 3 times 15, x minus, and x plus 3 plus 15 times 15. And on the other side,
once you expand, we will end up with a quadratic equation.
and that can be solved using the quadratic formula. Negative 45, positive 45 will be gone. 15x plus 15x,
That's 40x.
so this will give us 3x squared minus 30x minus 27.
And I can use my calculator to solve this quadratic program. Get my quadratic program here. And I can enter the three numbers for A, for B, and for C. Not both of them will be correct. You need to make your judgment. They are giving us a negative answer and a positive answer. And we are trying to solve for x in this case, which is the average speed. One of them would work. And we will reject the one that doesn't make sense to us.
So here, even though we have two answers for x, the only answer here will be 10 point, I believe 10.8, yes. And this is the speed,
The average speed when there was no wind.